So we were learning about for loops, right? And you can mess with whatever you need on my computer if you need to. Which basically looks like this, right? We have a statement that starts for, and we started out with, and it has three portions to it. To refresh your memory, it has a initialization statement, which will start out right now.
Steve, we got it.
We're writing int I is equal.
Oh, and it disappeared.
Did it disappear?
Yeah, it would disappear. Did you want to duplicate or extend?
Extend, because you can't do native resolution.
Let's do a second. It was just working. There we go.
There you go.
Okay.
Good. Good. All right. So as I was saying, I have a lot of stuff to get through today because there's a lot of stuff I've planned for your homework. So if for some reason we can't get to it today, well, I can always record additional stuff just to throw on for a lecture. So I don't really change the homework because they're good exercises for using for loops. So today what we're going to focus on is nested for loops. And now what's going on over here? All right, give me 1 sec, sorry. And getting, yeah, I suppose I could have gotten Eclipse pulled up all that during that. Also, there was a quiz today, so just if you're in the Japan section, email me for the code, and I'll give it to you. Let's see, and then we need lights because otherwise we can't see. Yeah, this switch over here. Oh, okay. Suppose we better. Yeah, that's fine. And full screen projector viewing. Boom. Awesome. So we were dealing with for loops. Intro code. All right. And what we were saying is that basically that for loops, they have this statement, right? They look like this weird statement, which is that they start with for, in other words, for each, and then we start with an initialization statement. For int I is equal to 0. And this first statement, right, is a for loop is made up of 3 parts. For int I is equal to 1. We start out by just running this exactly once. Now, normally we'll write for I is equal to 0, but when we're starting, just to make it easier to understand, because right now most of you start by counting with 1, so I'm not going to change that quite yet. But in computer science, we'll be starting by counting with 0, from 0. For now, we'll start by counting from 1. For int I is equal to 1, I is less than or equal to 10, I plus plus. So this is the initialization. This is the test condition, which means we will run this loop so long as this statement is true. I is less than or equal to 10. And then the second statement is and the third statement is I plus plus. And this is the update statement. So this is, remember, the test statement is tested at the beginning of each loop, and the update is run at the end of each loop. So this statement over here printed out, if you remember, system.println I squared is I times I. So, right, I would start out at 1. We'd check and test is 1 less than or equal to 10. Yes, it is. So we run the loop. Then we print out 1, because the current value of I is 1, squared is 1 times 1, which is 1. Then we'd go to 2. Then we would run this and update. I is now 2. Remember, I plus plus is just a shortcut. It's the same as saying I is equal to I plus 1, right? Where we take the value of I, get it, add 1 to it, and store it in the value of I. So this is actually pretty useful, being able to update a variable like that. So then it will go. So we update this to 2. 2 is less than 10. 2 squared is 2 times 2, which is 4. And then it'll go to 3 squared. So we'll go through all so the way this will work is that it goes through all the values. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the way we know, this is fairly easy to read. We start at 1, right? And we go through all the values up to and including, that equal sign means including 10. So it's all those values, and we're going to go in order one at a time. That's the way we read this. So I is going to be all these different values, right? And the hard part I find for students is just basically abstracting this out and getting it to the point where they really are comfortable with the way this looks. But you're going to get a lot of practice this week on how to write that. Now the best practice I found to do those is nested for loops. And what I mean by that is that a lot of times, a lot of other books I've seen what they do is that they introduce this concept, much later. And honestly, it's best to hit you over the head with it now. Get the worst out of the way right now. This is about the rather than just leaving it for later. Like we haven't even learned if statement yet, or how to write functions. But right now we're going to jump into what most students find difficult, which are nested for loops. Which is, for loops are statements, and they'll run whatever we put inside of them, which includes other for loops. So all that is that it's a for loop. It's a loop placed inside of another loop. So this is a basic nested for loop. So so let's look at the outer loop right now, okay? Just ignore the inner for loop, right? Just ignore the one that's bolded right now. I know that's counterintuitive to ignore the one that's bolded, right? So we ignore the one that's bolded for a moment. We'll just look at them independently. For int I is equal to 0, I is less than or equal to 5, I plus plus. What that means is that this loop's values for, this variable I, when it's going through the loop, is going to be the values 1 through 5. So 1, 2, 3, 4, 5. Now, it doesn't really do anything with those values. But what it does, but what we do with that is that this loop will run 5 times. It will run this inner for loop, which we're just going to gloss over and just let our eyes glaze over that because I don't want to get into that yet. And then we're going to print out a line, right? We're just going to print out an empty line. So we'll print out 5 empty lines. Okay, let's look at this. Go ahead and look at this inner loop over here. For int j is equal to 1, j is less than or equal to 10, j plus plus. So this inner loop over here is going to run 10 times, right? J's values are going to be 1 through 10 inclusive. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. That's 10 different values, right? And each time this inner loop executes, it's going to print out a star. So it's going to print out this star 10 times. So the way this works is that basically each iteration of the outer loop, it will do a full set of this inner loop and then print out an empty line. So our output is print out 10 stars, right? Because that's what the inner loop does. Print out a new line. Print out 10 stars, print out a new line. Print out 10 stars, print out a new line. Print out 10 stars, print out a new line. Print out the stars, and print out a new line. That makes sense to everybody so far? So the issue here often becomes like for students just sometimes just trying to figure out the best way to structure this. Now, a lot of you are going, well, actually, wouldn't it have just been easier for me to write this, like for int I is equal to 1, I is less than 10, I is less than or equal to 10, I plus plus, and just simply do this, system.out.println, assuming I could, learn how to type, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? Wouldn't have that been easier than just writing a nested for loop? Oh. That's 10 of those. If I want to replicate that, it would be 5. And you'd be exactly right. Writing this does seem a lot easier than the nested for loop. But what if I didn't want what if I didn't want 10 stars each line? What if instead I wanted 100 stars each line? Well, then I'm in the process of I'd have to, copy this and do copy 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Or type that out a bunch of times, right? And then maybe you're writing this and then you decide, well, actually what I needed was 50. And then you're like, well, now I have to count half of those and delete half. And so suddenly that becomes a bit harder. So using in multiple loops like this allow you to set it up so that you can just change a couple numbers and you can change the way this works rather than having to go in and modify everything manually. Okay. But it gets actually much cooler than that. We can actually vary stuff. So in other words, what if we write a loop like this? I'll go ahead and write this loop over here first. For int j is equal to 1. And I'll write what basically we had as the original example. J is less than or equal to 10 j plus plus. System.out.print. Now remember, what print does is that it doesn't print. It doesn't end the line. It just prints out a single character and doesn't put the next character on a new line, right? And print line is like me hitting the enter key. Okay? And let's go ahead and run this. So we've got our stuff on. So we've got our original one over there. And now if I want to change so let me just comment out the other stuff. Now if I just wanted to sorry, I should slow down because the problems we were having has got me in a rush, and I should just really slow down on this and take our time. So going back to what I mentioned, I can just change this to 50, this inner loop to 50, and now we print out 50 stars, right? I can change it to 25, and now this inner loop runs 25 times each time the outer loop runs. So that's an important concept to just remember. This inner loop executes fully each time, this inner loop will execute 25 times each time this outer loop runs, right? This outer loop runs 5 times, and each of those 5 times it runs 25 times, or maybe 20, or maybe 10, right? I can change it around very easy and just change it as I need to. But now what if I change it to this? Int I is less than, so this outer loop runs a grand total of 5 times, but this inner loop now runs a grand total of not a constant number of times, it runs a variable number of times. So the amount of times it runs I number of times. So the amount of times this inner loop will run now varies. Okay? It changes. Well, okay. How in the world do you figure this out other than writing it? Well, the answer is you just write it out. If you want to figure it out, of course, without running it, then what we need to do is write it out on over here on the board. Oh, come on. Okay. So in our first, so this is here's the dry erase marker. There it is. All right, so this outer loop over here, it runs I is less than or equal to 10, where I said 5, I plus plus. That's not gonna, that really doesn't work, does it? Asked for a camera crew. Haven't got one. I guess I'll just have to settle for using the computer. Sorry. Sorry. Terrible idea. Works in the 2168 classroom because I've got one behind me, but a whiteboard right behind me, but not here. Okay. So let's go ahead and instead we'll have to count it. We'll have to just type it out for ourselves and figure it out. Okay. So this outer loop will run once. I is currently let's like execute it just like as we're going along with it. I is equal to 1 currently. Okay, we go through and we create and we hit this loop. We're going to run this outer loop because 1 is less than 5. Okay. So now we get to this inner loop and we set j equal to 1. And now we run this inner loop if j is less than or equal to I. Is j less than or equal to I? Yeah, it is. So we run this inner loop and we print out a star. Okay? Cool. Now we update j to 2. Is j less, so now we test it. Is 2 less than or equal to 1? No, it is not. So we stop here and we print out a new line. Then we update I to 2. We get to this for loop, set I equal to 1. Is 1 less than or equal to 2? Yes, it is. So we print out a star. We update j to 2 now. Everybody following along with this?
No, you go over.
Okay. So the first time the first time we went to the loop is that first time we went through the loop, we set I is equal to 1 and j ran, and this inner loop ran I number of times, which was 1, right? So then we finished that version of loop and we created a new line. We updated I to 2. So now I is currently equal to 2. J is starts at 1. J starts at 1. And is 1 less than or equal to 2? Yes, it is. So we run the system.out.println statement. Okay, then we update j to 2. Is 2 less than or equal to 2? Yes, it is. So we print out a star. Then we update j to 3. Is 3 less than or equal to 2? It is not. So we're done with that for loop, and we print out another new line. And we update I to 3. Okay, I is equal to 3. And so now j is equal to 1, and while j is less than or equal to 3, we are going to run this loop, right? It's 3 now because i's value is now 3. So we go forward and we print out star because 1 is less than or equal to 3 is 1 or less than or equal to 3. Print out second star because 2 is less than or equal to 3. Update this to 3. Print out third star because 3 is less than or equal to 3. Update j to 4. And 4 is not less than or equal to 3. So we stop the loop and we print out a new line. So notice that what's happening. On the first, when I was equal to 1, we printed out 1 star. When I was equal to 2, we printed out 2 stars. When I was equal to 3, we printed out 3 stars. So when we run this code, we get 1 on the first line, 2 on the second line, 3 on the third line, 4 on the fourth line, and 5 on the fifth line. Is everybody following so far? Did I lose a lot of people, or? Okay. This is pretty nice. And we can do this, and if you want to see, we can print out some extra stuff just to show you. Just to make it clear. System.out.print. So now we're going to print line I. Just to make it clear. Line I over here. And I'll tab this so that we have a nice space. So we'll print out the what i's value is and what j's value is. So line 1, j's values were 1, and that was it. Line 2, j's values were 1 and 2. Line 3, j's values were 1, 2, and 3. Line 4, j's values were 1, 2, 3, and 4. Line 5, j's values were 1, 2, 3, 4, and 5. Is that making sense to everybody? Awesome. So that's pretty nice. We can now vary what happens in each line. So now if we go back to our original one where we had 1 through i's values were 1 through 5, and we printed out, instead of a star, we printed out i's value. First line we'd print out a 1, then second line we'd print out 2's, third line we'd print out 3's, fourth line we'd print out 4's, and fifth line we'd print out 5's. So some common errors that happen even to me, even as I make these errors all the time, even as I code stuff up. So let's go ahead and just say, switch this over like j is equal to 1, j is less than 10. This isn't an error over here, right? Now we're back to printing out 10 numbers each line, right? Constant number each line. Okay. Common error that even I make all the time, but since I know what it is, I can immediately fix it, is that rather than putting j here, I put I here. And this causes a real infinite loop, not one where we get an overflow, but like really real. So int I is equal to 0. So here, right, we're printing out 5 lines, but on each line, for int j is equal to 1, I is less than or equal to 10. Notice how I have I here rather than j. It's very easy to do that because you're just kind of on autopilot. Well, okay, this loop will run so long as I is less than 10. Well, I was 1, I is less than 10, so we run this loop. We increment j. I is 1, let's run this loop again. Increment j. I is 1, that's less than 10, let's run this loop again. So notice how I'm testing the wrong variable over here, and as a result, it's just running forever. See if I change print j, if I change this to a print line, let's see if that changes this up and see. So notice that it's just running forever because I have the wrong variable here, right? Or another common mistake is that if you're getting an infinite loop, I put I++ here. So I'm checking if j is less than 10, but I'm never actually going to change j, right? Instead, I'm accidentally going to change I. And so I'm stuck in this inner loop, right? J is always 1 now. All right. So let's go and look at some really weird, some interesting puzzles now, because we're going to try to figure out how to write these lines. So we've got ... 1, ... 2, ... 3, ... 4, and 5. All right. What for loop would give us this? So what we have to analyze is basically just the way we're building this, right? Just because the way we can print stuff, we basically have to do this one line at a time, right? So first we want to figure out how many lines are we printing out, right? So our outer loop is going to run 5 times because we have 5 lines, right? Because we can print out, our outer loop is going to handle each line individually, right? That's just the way it's going to work because we print out each line one at a time. And then we figure out the inner loop, which is the pattern within each line. Okay. So let's look at this. The first line we're going to have a 1. The second line we're going to have a 2. The third line we're going to have a 3. The fourth line we're going to have a 4. And the fifth line we're going to have a 5. So yeah, these dots here are a bit troublesome, but for right now I can print out all these numbers pretty easily, right? So let's do that. So let's just focus on the outer loop first, which is always what I like to do. For int I is equal to 1. And the values for I are going to be 1 through 5 because we're doing 5 lines, right? Does that make sense for everybody so far? Okay. So we've got 5 lines, system.out.println, and what we know is that we've got basically this kind of going on at the end of each line, right? Oh, still got this infinite loop program running over here, so that's probably... So we've got 1, 2, 3, 4, 5, right? Now that isn't ... 1 and then ... 2, but we've got the tail end of this working right now, right? So, all right. And then I know I need to put dots in front of each line, okay? So I need an inner loop to do that dots in front of each number, right? So let's just, put in a constant number of dots. J is equal to 1. And what's the most number of dots I needed? 4. I needed 4 dots at most, so I'll just start there. J is less than or equal to 4. J plus plus. System.out.println. Print. Okay. Star. So now, well, it was periods though, as opposed to asterisks. So I've got ... I'm sorry, ... 1, ... 2, 3, 4, and then 5. Okay. So now I need to, but I didn't have a constant number of dots each line, right? Notice how I'm just built. This is a tough problem, but rather than like trying to figure it out all at once, I'm building it up piece by piece, right? I looked at the outer loop. Then I look at the inner loop, right? And now I've got to go with a constant number of dots on each line. But what I really needed was a variable number of dots each line, all right? So I needed to, so basically this one had 4. This one had 3 on there. This one had 2. So I'm subtracting like 1 each line, right? So I need 1 less star, then I need 2 less stars, then I need 3 less stars, then I need 4 less stars, then I need 5 less stars. Well, okay. What if I subtracted I over here? What's that going to get me? It's going to get me close. I get ... 1, ... 2, ... 3, 4, 5. I'm like off by 1 here, right? And the reason is because if I do that, so what's going on here? Let's just look at it and just ponder on this. So the outer loop runs the same number of times no matter what. But what's going on here with the inner loop is that it's going to run 4 minus I times. So this first line is 4 minus 1, so it runs 3 times. The second line is 4 minus 2. The third line is 4 minus 3, which is 1 time. And then 4 minus 4, which is 0, so that's not going to run at all. And then we had -1 over here, but that doesn't mean we don't print out something or do something weird. It just means that the loop doesn't run because it's not a true condition. So what do we need to do to solve this? Yeah?
You subtract the I and then add 1 with the 4 minus 1.
Yeah, we could totally add 1 over here because we're off by 1, right? There's actually a couple different ways to solve it. That's 1, right? So now we're printing out 3 plus 1 dot, 2 plus 1 dot, 1 plus 1 dot, 0 plus 1 dot, and then -1 plus 1 dot, so 0 dots. Okay? Another solution is, well, if 4 isn't working, maybe 5 works, right, over there, which is I'm sure what the other half of the class was thinking, right? Because as I said, there's plenty of ways to do this one, right? But notice how basically we experiment to solve this problem, okay? And you'd be surprised how well experimentation works, right? And that's the strategy that they suggest using. First, write the outer loop from 1 to the number of lines. Now we look at the dots. There's some dots, 0 on the last line, and then a number. So the number of dots you have, that's related to the line number. 0 on the last, 1 on the second to last, 3 on the third to last. So let's see. So now they've got, let's see, mapping loops to numbers. So let's see. Suppose we have this outer loop right over here. For int count is equal to 1, count is less than or equal to 5, count plus plus. System.out.print ... What statement in the body would cause this loop to print? 4, 7, 10, 13, 16, right? And the question, and they show that and the idea here is that basically notice that each of these goes up by 3s, right? Sorry, each of these goes up by 3s. 4 by 7, that's separated by 3s. 7 by 10, that's separated by 3s. 10 by 13, that's separated by 3s. 13 by 16, that's separated by 3s. But they're not multiples of 3s, right? 4 isn't a multiple of 3, neither is 7. But they're all off by a multiple of 3 by 1. So if I did, you know, if I printed out 3 times count, so 3 times whatever this is, so 3 times 1 plus 1 gives me 4. 3 times 2 plus 1 gives me 7. 3 times 3 plus 1 gives me 10. So there's a way, so we can figure this out by just basically like trying to figure out how we, by figuring out the numbers involved in this. So let's go ahead and copy that into our code for a second. So, right, if we print it out, so again, this is the same kind of approach to solve this one. We would experiment. We've got our count over here, right? And we wanted 4, 7, 10, and so on and so forth, right? Right now we've got 1, 2, 3, 4, 5. Okay, well, we notice that 4, 7, and 10, they're separated by 3s, right? 4, 7, and 10, they're separated by 3s. So in that case, we can multiply count by 3, and we can get 3, 6, 9, 15, right? And if we compare that to what we want, which is system.out.println 4, 7, 10, 13, and 16, if we compare these to what we got from each other, we notice that these are all off by 1, right? If we just added 1 more to each of these, we'd have what we want, right? So we just do that. Count times 3 plus 1, and we get what we need. So now let's go ahead, and the question they are asking is, question they're asking is, how do we get 2, 7, 12, 17, 22? And one of their suggestions is, if we really need to see the patterns, we can write down a table, right? So if we, this is asking about the same loop, right? So count values are going to be 1, 2, 3, 4, 5. The number we want to get is 2, 7, 12, 17, and 22. And we notice the same relationship, right? That these are separated by 5s. So 5 times count would give us, 5 times 1 would give us 5. 10 times count would give us 2. 5 times 2 would give us 10. 3 times 5 would give us 15. And we notice that basically that if we get these values, they're all separated by, they're all off by 3. So we could subtract 3 from that amount that we need. So we can just create a table to just figure out the values like that. All right. So let's go ahead and just show you that one. 5 minus 3 would get us 2, 7, 12, 15, 17, which was the values we want for this one. What about this one over here? What statements in the body would cause us to get 17, 13, 9, 5, 1? Each time the count goes up by 1, the number printed should do what? Each time count goes up by 1, we're losing 4, right? So each time it goes up by 1, we need to subtract 4 from our number, right? So -4, -8, -12, -16. So we're decreasing by the appropriate amount each time the count goes up, right? But we're all off by, all these are not equal to these, right? These are all negative numbers and these are all positive numbers for 1. But if we look at them, the difference between 1 and 21, -20 and 1, that's -21. The difference between 5 and -16 is -21, right? All these are off by a grand total of -21. So, well, off by positive 21, rather. So if we do 4 times count, and then add 21 to our end total, we get the values we're looking for. So here we were looking, so going back to our original value problem, if we wanted to use the table method to solve it. 1, we wanted 4 dots on the first line. So we wanted, so the way they suggested this, the way they came up with solving it is we need 1 less dot each line, so -1 times the line, -2, -3, -4. And each of these that we want, the number we want is off by a grand total of 5. So -1 times the line plus 5 was their answer. Which looks a bit harder than mine, but again, this just shows that there's a lot of ways to solve these problems. So now, this one I like. Let's go ahead and modify the code that we started with. The .1, .2, .3, .4, and 5. We're going to modify this so that we get, so that basically there's the same number of characters each line, but now we've got like 1 after here, 2, then 3, then 4. Okay? So this is going to require us to do multiple. So again, I'm going to solve this the way that I started by solving it, which is that, well, we've already got the first part of this solved, right? Okay. So rather than, but because we'll need more, what I'm going to do is I'm going to separate, I'm going to now put the, because we're going to possibly have characters after the number, I'm going to put my system.out.println separate from everything else. Okay. Okay, doesn't change the output. I'm just moving the new line over here. And now again, I know I need to print out a bunch of numbers, sorry, a bunch of dots, and I need to print out 4 of them at most. Println dot, print dot. We're going to put that in a for loop. For int j is equal to 1, j is less than or equal to 5, j plus plus. Okay. And that's going to get me somewhere close. I need 4 dots over here, not 5 for the last line, so I'm going to put 4 here. So last line is correct, but nothing else is. Okay? Now, you might be stopping in... now, one of you might be thinking for a second, wait a sec, you mentioned that, you know, you can't declare a variable twice, but you have int j being declared here and int j being declared here. Well, this has to deal with what's called scope, which is basically how long do variables live for? What is the lifespan of a variable? And if you think about it, it makes sense that basically variables need to stop being used at some point, right? Otherwise, the first person who uses int x in their own program, they're the only one who gets to use int x. Then everybody else can't use int x, right? So variables only exist within the paragraph, the code block that they're in. So that means that basically over here, this int I only exists inside this for loop, right? If I tried to print out I out over here, it's going to give me an error saying it can't find the symbol I, because I was created within the for loop, only exists within the outer for loop. Same with these int j's that we have over here. Okay? J is less than or equal to 5 minus 1. Sorry, 5 minus I. This J only exists between. So this J only exists between between here and here. Okay? So that means that it's gone, so we can declare another variable named J over here. Going back to our problem, dot 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 1, dot 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 2, dot dot 3, dot 4, 5, and a bunch of dots. So, what are we going to do now? We need to, we need to adjust the number of dots that are following. So, we want 4 here, yes, but we want only 3 here, we want 2 here, we want 1 here, and we want 0 here. So, rather than starting with, so we want to continually keep adding the number of dots we're going to add. But rather than starting from, so then you might start flailing around and going, okay, we wanted 4 plus I. What about that? What if I did 4, right? We had 5 minus I over here. What if I do 4 plus I? Well, that's going to give you way more than you need, right? Because we're adding 4 plus 1, then 4 plus 2, then 4 plus 3, then 4 plus 4, then 4 plus 5 dots. Okay? But that seems to be putting in the right direction because we're adding more and more dots. The more lines we have, the further down we go, the more dots we're getting. So, what if we do 4? What if we did 0 plus I? Okay? 1, 2, 3, 4, 5 dots. Oh, well, that's the same as saying 0 plus I is just saying we need to have I dots there. And that's close to the correct answer, right? But we just don't need a trailing dot over here. We needed 1 on the second line, 2 trailing dots on the third line. So what about I minus 1? Right? And seeing how basically experimenting and notice what you're actually doing and thinking about what you're doing helps you figure it out. Now, the way they go about it with their tables is, they have line minus 1 is there as well. So they figured that out the same way we did. Okay, but that just to only printing out this kind of stuff is boring. So one of the problems we're gonna have is basically dealing with complex figures, drawing some nice ASCII art, nice symmetrical stuff. So. And the reason for this is because these allow us to print out some really nice stuff. So when we get to your first timed lab, you're probably going to have one of these. And your first time lab isn't this Friday, but it's going to be next week. And right now I'm thinking about having some fun by changing up the way we're going to do this stuff. But we are going to. But let's look at this figure and try to figure out maybe how we could print this other than copy and pasting it in, right? How can we figure out how to do this, right? If we look at this, right, we have this bar on the top and the bar on the bottom, so they're kind of identical and they're kind of irrelevant. They don't really change that much. But if we notice like the similarities between each line begins and ends with bars. And then they have a certain number of spaces, right? Because spaces actually are characters that exist, right? They have actually, since we're dealing with monospace fonts, we can count this up. This one has 1, 2, 3, 4, 5, 6 spaces. Then the less than greater than, and then 6, right? And no dots in between them. This one we take 2 spaces away on each side, and then we put 4 dots in between these guys. Then we take another 2 dots away on each side, and put another 4 dots in between these symbols. And then we take away another 2, and put out 4 dots over here. And then this other character, this is just that flipped around. This side is just this side flipped around. So that's just another 4 lines that are done with a for loop. So the idea here is basically we want to, when you think about this, you want to design the program. You don't want to just rush in. Think about it. Write a description. Write some pseudocode down. The idea of what you need to do to solve this problem. Okay? And then we use that to decide how we need to write it. So the next thing we have to do is then figure out how we do the for loops. So let's look at like the strategy of drawing this box, this 12 by 7 box of stars that we look over here. We'd want to print 12 stars at the top, and we'd want to print 12 stars at the bottom, right? And then each of these 5 lines in between, we'd want to print a star. For each of these 5 lines, we'd want to print a star, print 10 spaces, and then print a star. Print a star, print a bunch of spaces, and print a star. And we just do that 5 times total. So, again, with this is that to figure out how do we print this figure, we've got the top and the bottom, right? And then we need to do figure out how to do the top half, which we kind of just went over. And then we figure out how to do the bottom half, which is just the top half that's done upside down. So let's go ahead and write a program that's going to do that. Okay. Weird ASCII. Okay. So let's see, so what they did is that they break this figure up into multiple parts, right? They have a method for each part. Because remember, we can write methods to automate this. We have the line, we have the top half, the bottom half, and then we have the line again. And the idea is now, since we're bringing this up into methods, we can figure out each part independently. So let's do that. So first, let's figure out draw. The first thing we want to do and the last thing we want to do is draw a line. And remember, if we call back from a week ago, methods are just extra commands we can add to the program. Public, static, void. And right now we're dealing with what we call void methods. Draw a line. Which don't return any value. They don't give any information back. They just perform actions. So to draw a line, that was, checking back with our characters, that was it was a pound sign and then 16 equal signs. So system.out.print. We're going to print out the pound sign at the beginning. Then we're going to print out a pound sign followed by a new line at the end of that line. And in between them, we need 16 stars, right? We need 16 equal signs, not stars. So for int I is equal to 1, right? I is less than or equal to, and we know if we want 16 of them, we just put 16 over there, and then we say we just increment the counts by 1. So this will be all the numbers 1 through 16. Common mistake I see over here is people put a semicolon over there, right? And you saw me just do that right then. And what this does is that it actually means that the for loop just ends over here. It means it doesn't do anything. We're going to run this for loop 16 times, and its body does nothing. And it will basically run whatever in here once, because this will actually be like a separate piece of code over here. So if your for loop isn't working correctly, and it just seems like it's running once, it might check to see if you have a semicolon over there. So system.out.print equal sign. So now we print this out, and we get this over here and this over here, right? And the nice thing about having this in the method is I don't have to copy paste this, right? I've just got 2 lines. So now let's work on the top half. Public static void draw top. Okay, first let's remind ourselves what it looked like. And we'll do that by having a nice reference to go over by copy pasting the ASCII into some comments over here. What do we want to draw? I'd very much like to draw. Let's see, it didn't work as easily as I thought it would, so arg. There we go. That's what we want to draw, right? So we know that there's going to be 4 lines. So first off, we know, let's think about this. How many lines does this encompass? This encompasses just 4 lines. So we know that the outer loop. So first off, we know we need a nested loop because the inside of each of these things varies, right? So the outer loop, we need 4 lines, so it needs to run 4 times. Is equal to 1. I is less than or equal to 10, is equal to 4. I plus plus. So this will run 4 times. System.out.println. It's going to, we'll have the print line at the end all by itself. And then we know that basically it starts with a bar, or a pipe, as we call it. And it ends with that pipe symbol at the end. Okay? Okay, so now if we do the draw top goes in between each of these lines. So we get this. Oh, we have print lines here instead of prints. Right? So, well, that doesn't look anything like what we need. So what do we need to do next? Well, we need to fill it out. Let's go ahead and just make we're going to make every line the same, okay? First off, we're just going to print out the same one each time. And because we've got 0 spaces on the top and 0 dots on the top and no spaces on the bottom, I'm going to start out by just making everything in the top, like the top, but keep in mind that we need to add dots in the middle. So what do we have? We have to print out 6 spaces, right? For int j is equal to 6. J, and you can give these more meaningful names, right? Like spaces is equal to 0. While 1, again, habits are dying hard here. Less than or equal to 6 of these. Spaces plus plus. System.out.print a space. I'll copy that later. Then we need to do system.out.print. So we print out 6 spaces. We print out this thingy. And then we're going to print out a bunch of dots in between those, right? But we don't know. But for right now, we're making it the same. So I'm going to just say that we're going to start with 1 dot. We're going to print out 1 through 0 dots. dots plus plus. And then we print out another one of these thingy, another one of those. Let's see our progress so far, by the way. Always check your progress. In fact, I should probably, if you're just starting, you should probably like check your progress each time you write these lines, rather than trying to figure it all out all at once. So 6 spaces, then this thing, and now we need 6 more spaces after that. Which should all, and we notice that basically if we've got 6 here, we've got 6 here. If we've got 4 spaces here, we've got 4 spaces here. If we've got 2 here, we've got 2 here, and 0 here, we've got 0 here. So it always varies. So it always varies by the same amount. So now it all looks identical to that top line. Okay. So let's think about this for a second. What about our spaces? We lose 2 over here, and we lose 2 over here each time. We basically lose 2 spaces each time we have a line. So, okay. So minus 2i, because I will be increasing. So let's go ahead and see how that works. And again, I'm just going to copy paste this over to here. So the first line now has 4 spaces missing. These have 2 spaces. So, sorry, we've got 4 spaces on the first line rather than 6. 2 over here, then none and none. So we really want 2 more on each of these. So we can increase this to 8. Does that make sense to everybody? So now we've got 6 over here, 4, then 2, then 0. Okay, what about our dots? We need 0 dots over here, then 2, sorry, 0 dots, then 4, then 8, then 12 over here, right? So the amount of dots goes up by 4 for each line, right? So if we do this, however, we get, oh, I need dots, not spaces. We get 4 on the first line, and the first line we wanted 0. 8 on the second where we wanted 4, so that was just 4 too many. So we could, you know, so there's a couple things we can do. We could do I minus 1 over here, right? Because this will do 0. This will subtract 0 on the first for line 1, then 4 on line 2. And again, there's multiple ways to do this, because the nice thing about math equations is that there's multiple ways to write, you know, expressions. So there's the top of our dot. And just by thinking about it, we can get there. Okay, what about, we need a draw bottom now. Okay. Okay, so draw bottom. Well, we just copy and pasted draw top. So draw bottom, you know, looks the exact same as draw top right now. And that's not what we want. What we want is that we want it flipped. So what we want basically is that we want 0 spaces on the first line, right? So let's actually just work on this from this. So we can work on this by figuring out the spaces first, right? And the dots. And because we've only, and I think I'm just going to start on the dots first, right? So let's go ahead and put this back to having a constant number of dots, because we want 12 dots in between everything, right? So in between we've got 12 dots here, right? And then we want 8, and then we want 4, and then we want 0. Okay, so we start out with 12. So each line we want to subtract 4 of them. Well, fortunately that subtracted too much, so we need to do I minus 1 over here, right? Because now if on the first line of the bottom we'll subtract 0 dots, then the second we'll subtract 4, the third will subtract 3, as opposed to what we had earlier where we were subtracting 4 on the first line. Okay? Now we need to deal with the number of spaces. The way this works is that like we start out with 0 spaces on the first line, right? We start out with 0 spaces on the first line, and then we want 2. Then we want 2 here, and then 2 here, then 4 here and 4 here, and then 6 here and then 6 here, right? So we start out with 0, and then we add 2 each line. So 2 times I. So that it will add 2 spaces here, then 4 here, then 6, and then 8. But what I really wanted was 0, 2. So again, I can just subtract 1 from the I, or I could subtract 2 over here, right? There's a lot of different ways to think, to think about it. I'm just trying to show you as many there are. So now we have 0 spaces here, then 2 spaces here, then 4 spaces here, then 6. And if we just copy and paste this over to here, right, because the two space size and spaces should be identical, we get this. All right. So because of what's going on here, and because basically we would have like maybe 15 more minutes to get into stuff that we needed to for our lab. I'm going once my office hours are over today, I'm going to record a lecture. Okay, I'm going to record another lecture on the next portion, which is what you need to do for your homework. And maybe I'll probably do a couple more problems of these on Monday. But here's the way it's going to work. I'm going to record a bit of material on how do you write methods to solve these problems. I'm going to go over basically the stuff from Chapter 3, which is some stuff that you need to solve this homework. When we come back on Monday, now I expect you to watch that before the lab starts, or at least watch it, what you need in the lab. And I'm going to try to make the videos a bit shorter rather than the full hour long, so like 15-minute segments at most. Then when we come back on Monday, what we'll do is that we'll do a flipped lecture. Basically, the idea is that I'll maybe work for maybe 15 minutes to a half an hour on some problems, okay? And then the rest of the time will be dedicated for you to work on more of these problems. So I'll give you some problems so you can work on the homework. You can also work on something that I'll give out in class for you guys. And we'll see if that's will count as a quick grade or as an additional lab. I'm not sure how that will work because... So the homework this that I'm going to give out this week is all stuff on for loops. The only thing that needs to be done is that they're going to need to be put in various methods, which I'll show you. So if we go to intro, assignments, let's see. I think it's this one, loop problems. Nope, it's not this one. It is the, it's lab 3. So basically I'm going to reorder them so that they're in order from hardest to smallest. But let's see, I know you can't see it, but it's a problem where you have to write the song method that prints out the song 99 bottles of beer on the wall, writing a method that prints out a multiplication table, writing a method that prints out the summation of squares, and then I think I'm going to then you'll have 2 ASCII figures you need to draw. So, and each of those will be worth 20 points total for, so you've got 5 problems, each are worth 20%. So if you can't get one of them, it's still a B, a passing grade, but they shouldn't be too bad. And we do give partial credit on the problems, but the goal is for you to get all of them. And again, what I'm going to do is I'm going to make a lecture so that in advance so that we can have more time to work in class. So I'm going to try to move to doing more of these flipped lecture kind of situations. So now I'm aware that how many of you don't have a laptop you can bring to class? Okay, one student. And let's expand that a bit. How many of you don't have a laptop that you would trust to get any work done on? Okay, a couple more of you. So when we come back here on Monday, again, what we'll do is that we'll pair up. So, and just pair up with somebody, with anyone on Monday, and we'll get to work on that. So I've got to get to another lecture. So, yeah.